The perfect cosmic storm. Jupiter is the largest planet in our solar system, with over 90 known moons orbiting it. Some of these moons are tiny, no more than mere fragments of rock, while others are colossal. Ganymede, for instance, is the largest moon in the entire solar system, bigger even than the planet Mercury. Then there's Callisto, an ancient, heavily cratered moon, and Europa, with its icy surface hiding a potential ocean underneath. Io, with its volcanic fury, stands out as the most geologically active body in the solar system. Now picture this. Each of these giant moons, once gracefully orbiting the gas giant, suddenly deviates from its path. Perhaps a gravitational disturbance from a passing celestial body sets off a chain reaction. Or maybe an internal instability causes one moon to shift its orbit. Whatever the cause, these moons no longer follow their predictable paths. They are now locked on a collision course. The impact. The first collision would be like witnessing a planetary apocalypse. Let's say Ganymede and Callisto, two of the largest Jovian moons, collide. The force of the impact would release an energy equivalent to billions of nuclear bombs going off simultaneously. Ganymede, with a diameter of over 5,200 kilometers, would smash into Callisto, whose heavily cratered surface is a testament to ancient impacts. The explosion would be so immense that the surface of both moons would be torn apart, sending fragments of ice, rock, and possibly even oceanic water from their subterranean layers hurtling into space. From Jupiter's perspective, this event would light up the sky like a second sun. The collision's brightness could be seen across the solar system, but the real danger would come after the impact, when the debris from these shattered moons begins to spiral around the planet. The deadly debris field. Once these colossal moons are reduced to jagged fragments, they form a vast debris field. Millions of rocks, chunks of ice, and metallic fragments would begin orbiting Jupiter, each moving at thousands of kilometers per hour. This newly formed ring of debris would be chaotic and unstable, constantly colliding with itself and reshaping the field. Every now and then, larger fragments would smash into one another, generating even more fragments and perpetuating the cycle of destruction. The debris field would be a dangerous and unstable environment. Any object entering this region would be bombarded by high-speed fragments, rendering spacecraft or probes completely destroyed. Even if the debris pieces were as small as pebbles, the speed at which they traveled would make them as lethal as bullets. Over time, this field would become a swirling belt of death around Jupiter, similar to the asteroid belt between Mars and Jupiter, but far more hazardous. Gravitational havoc. Jupiter's immense gravitational field plays a huge role in shaping the orbits of its moons. In fact, it's one of the reasons why so many moons can orbit the planet in relative stability. However, once these moons collide and form a debris field, Jupiter's gravity would turn into a double-edged sword. The gravity would help trap most of the debris, keeping it orbiting the planet in a tight band, but it would also act like a slingshot for some of the larger fragments. These massive chunks of moon could be flung out of orbit, ejected from the system like cosmic missiles. Some could head toward other moons, creating a domino effect of collisions and further destruction. Other debris might be drawn inward toward Jupiter itself. The gas giant's upper atmosphere, made of swirling hydrogen and helium, would begin to light up as pieces of debris entered and burned up. Some of the larger chunks, however, would survive the descent and smash into Jupiter's atmosphere, creating massive storms and shockwaves across its surface. The fate of the remaining moons. The surviving moons would face a grim reality. With a deadly debris field orbiting their parent planet, every moment would be a gamble. The largest moons, like Io, Europa, and others, would be at risk of being bombarded by this constant rain of high-speed debris. While many pieces would burn up or crash harmlessly into their surfaces, larger fragments could cause catastrophic damage. Io, known for its intense volcanic activity, could be hit by a fragment large enough to trigger a supervolcano on its surface, sending plumes of lava and sulfurous gas into space. Europa, with its icy shell and hidden ocean beneath, might experience impacts that crack its surface further, causing geysers of water to shoot into space. Each moon would be scarred, cratered, and damaged as they tried to survive in this violent new environment. life in the shadow of chaos. If there was ever any hope for life on Europa or any of the other moons, this collision event would mark the end of that possibility. Europa, which scientists believe may harbor a subsurface ocean beneath its icy shell, has long been considered one of the prime candidates for extraterrestrial life. However, the constant bombardment from the debris field would obliterate any fragile ecosystems that might exist beneath the ice. The ice covering Europa's surface could be broken apart by repeated impacts, allowing harmful radiation from space to penetrate deeper into the moon. Even if there was microbial life or more complex organisms hiding in the ocean, they would stand little chance of surviving the ensuing environmental chaos. A ringed Jupiter? In time, if the debris field stabilized, Jupiter could begin to resemble another ringed planet in our solar system, Saturn. The fragments of shattered moons would settle into an orbit around the planet, forming a new, vast ring system. Unlike Saturn's ethereal rings made mostly of ice and fine dust, Jupiter's rings would be a gruesome reminder of the catastrophic collision that had taken place. The rings would be jagged, uneven, and full of heavy debris, an orbiting graveyard of what were once some of the largest moons in the solar system. These new rings would cast long shadows across Jupiter's atmosphere, blocking out sunlight in certain regions, and adding to the planet's already eerie and alien appearance. From a distance, the ring system would look magnificent, a halo of destruction surrounding the gas giant. But up close, it would be a deadly, hostile environment where collisions between debris fragments are frequent and unforgiving. The bigger picture: threat to the solar system. While the immediate destruction would be confined to the Jovian system, the aftermath could have far-reaching effects across the solar system. Jupiter, with its massive gravitational influence, is often thought of as a protector of the inner planets. Its gravity draws in and absorbs comets and asteroids that might otherwise pose a threat to Earth or Mars. However, after the moon collisions, Jupiter's protective role could be compromised. The newly formed debris field around the planet could act like a barrier, blocking or deflecting smaller objects that Jupiter might otherwise capture. This could lead to an increase in the number of comets and asteroids traveling toward the inner solar system, increasing the risk of impacts with planets like Earth. Furthermore, some of the larger moon fragments could be ejected entirely from Jupiter's orbit, becoming rogue objects traveling through the solar system. These large pieces of moon could potentially cross paths with other planets or even the asteroid belt, leading to more collisions and chaos on a wider scale. The idea of Jupiter's moons colliding and creating a deadly debris field is a terrifying one. It would turn the Jovian system into a nightmarish realm of destruction, where once mighty moons are reduced to fragments and the planet itself is encircled by a ring of death. This catastrophic event would change the landscape of the solar system, leaving a permanent scar on the universe's most massive planet. What was once a majestic system of moons orbiting a gas giant would be transformed into a scene of cosmic carnage, where survival is uncertain and the danger of collision is ever present. In this new reality, even the vastness of space would seem small, and the stability of the cosmos as we know it would be forever shattered.